So some of you might know what square numbers are already, but I kind of need to know, how do I know what square numbers are? They're on the wall over there, but where do they come from? David? Good. The square numbers are the result or the product of another number squared. Okay? So, out of this list, the square numbers, which is compared to that, are 16 and 25. And how I know they're square numbers is because 16 is 4 times 4, and 25 is 5 times 5. So that's how I know, that's how I get the square numbers. So if I said to you, what is the 7th square number? How do I find it?
7 there. Oh, sorry, no.
No, I can't. What do I do? How do I work out the 7th square number? 7 times 7, good, which is 49. Yeah. Now, here's the thing. This unit is a non-calculator unit. So how would you answer that question in a test? Well, if you're in this group, you yeah. Don't be afraid to look at stuff or something. Okay, square numbers. So we find the square numbers. Any ideas why they're called square numbers?
Said.
Because I said.
No.
That can't be a reason. Go for it. So if you had 16 counters, 4 lots of 4, if you laid out 4 lots of 4, you would have a square. 4 times 4 would give you a square. So it's also 16 would be the area of a square that is 4 by 4. It would be 16, that was centimetres. It would be square centimetres. Statement to make, also.
So
I'm just making sure. So does anyone know what the square roots then of a number is? Some of you are still struggling to read it. What does square root look like? Symbol.
well, square root would be the kind where it's kind of like a line down, like the diagonal line up.
Being on guard. So that's what we would say is a square root. So we're looking for what number squared, or what number times itself, equals 36. And the answer is 6. Now, because you're working at slightly above M1, some of you might know Mr. Potts on the card, I remember. So the answer to this, square root of 36, is actually 6
Times. No, 6 and negative 6.
6 and. Because 6 times 6 equals 36. That's why it's square root. But also, negative 6 times negative 6 does equal positive 36 as well.
Negative something.
For those of you that don't know. I'm not going to be so worried if you don't do both answers. Oh, you might get extra credit. But you won't lose any credit if you don't say it. Now, just address them. Let's move all the way up to.
Hold on. You pick that.
This, I think, is only square roots. Is that what it's about?
Is it square root is equal to and
Okay, right. Let me. You will notice that on this booklet, Riley, get the chair, that means you have to be super okay. You'll notice that some of them have Yes, you're allowed a calculator. And some of them have, no, you're not allowed a calculator. Yeah. Squares and square roots, great. I'm going to give you 5 minutes to do a few, and then I want to talk about cube roots.
So so would every square root have like, if you say, square root of 100 is 10,
Yeah.
and times 10 is 10, but also 10.
Yes. Definitely.
Yeah, how?
Right, just want to check. It says list the perfect squares up to 225. They are good to remember so that you can calculate square root quickly. Perfect squares are.
The squares of even numbers.
Tell me what they are. And they're not square of even numbers. 1, 4, 9, 16. They're on the wall. So, the perfect squares are another name for the square number. Okay? Because we can say that 2 squared is 4, but we could also say that 2.3 squared equals. You tell me how you calculate that. You do that for me? Some of you are doing what I'm not asking you to do. I asked you to put the sheet away. Pay attention to me. Because if I asked you to do 2.3 squared on those calculators you got borrowed, 5.29. Hopefully you all did that, because as long as that comes up in the test. Now, this is a perfect square. This is a square, but it's not a perfect square. Because it ends up being a decimal. So, it would still be if a square had the side length of 2.3, the area of the square would be 5.29. It's still, technically, we could say it's a square number. But it's not what we call a perfect square, and therefore we don't call it a square number. Yeah? So there's a difference between squaring something and ending up with a nice integer, and squaring something. This is still squaring, but we don't get what's called a perfect square. So the perfect squares are 1, 4, 9, 16. What is the 11th perfect square? 129, I know. Okay. Just a couple of things then. Over to you. 4 squared. 16. 11 squared. Yeah. 7 squared. Okay. 49. Okay. All right. Got squares. Square root of 9. Okay. Oh, 3. Square root of 81 found. 9. Square root of 100. 10. Square root of 324.
I'll keep my hand up. That would be.
Oh wait, no. Oh no.
18.
Is it 18?
Yeah.
Yeah.
It is 18. Square root of 4 squared.
Oh, 4.
4. Notice the square root is the opposite of square.
So it just equals out.
Just here's what I want you to get though. Do we all know what 5 cubes is?
Oh wait. I'm gonna say that.
Does anyone not know why?
Oh,
Not know why?
I know it. Oh.
Yeah, so we do it 3 times. 2 to the power of 5 is 2 times 2 times 2 is
32.
Yeah.
4 times 4 50 times 2 is. Now, I will say, how do I know? Well, a lot of these, it's very good to remember. What is this? This one. Ours.
Isn't this like a
What's the cube root of 27? 3. Why? Well, the square root is what number times by itself twice gives it. The cube root is what number multiplied by itself 3 times gives 27. What's the cube root of 125? 5. What's the 4th root of 16?
2?
2. What's the 50th root of 1?
So hard. 1.
1. Good.
That took like a year.
So, what I would say is, certain numbers we need to kind of get used to seeing, where we've got squares and cubes and roots and things like that. The main numbers are on the board, in fact. The nice and easy ones. Things like 9, 81, 100, 225, 16, 120. These are all ones generally we should know without having to work them out on a calculator. Yeah? So I should be able to tell you, you should be able to tell me, for instance, that the 5th root of 32 is
Oh, 2. Like 2, yeah.
it's 2, right? And you might say, how am I supposed to do that? How am I supposed to know what number times itself 5 times makes 32? How am I supposed to know? How am I supposed to work it out?
Good luck.
It is a bit of a, do you remember? Now, if I said to you, what's the 5th root of 61?
That's gonna be like.
It's going to be a decimal, and I've been asking you to do it on your calculator. Can you do it? This is a check, can you use a calculator? Because those that are not doing it and haven't got a calculator and didn't bother picking it up are not doing it and are not going to be able to do it. Because it is actually something some people can't do it.
2.27544 2.2754432. Okay, next. Second. So second on. 12 second. Let's see, no, before you talk about
You don't know? Ask someone. I think we need to convert 2.28. I've rounded it. It's either calculator. Go to mode. Classic. It's good now. You need that. This is why, ladies and gentlemen, are you all listening to one of the final things? This is why things like this, a lot of calculators will do this roots thing slightly differently. If you don't regularly use the same calculator, if you're one of those, I'm going to borrow my friends, they might do it differently. So come an assessment, you might borrow one that you're not used to using, and suddenly something you knew how to do becomes hard. Even though you know what to do and you understand it, finding that button on the calculator. Okay, so try and be consistent, have your own calculator always. Calculate, and when your teacher says, can you do that on your calculator, please? You have your calculator out and you do it. You don't wait for your mate to do it for you.
Yeah, this
Yeah.
one's
All right.